Dear students, in this video we will be discussing about runtime polymorphism. What does it mean of runtime polymorphism and how it can be achieved in C++. So, as we have discussed many times, compile time polymorphism, now we will discuss runtime polymorphism. Basically, in C++ there are two types of polymorphism, compile time polymorphism and runtime polymorphism. So far we have discussed compile time polymorphism. Compile time polymorphism is achieved by function overloading and operator overloading. We all know that how to overload a function and what does it mean by overloading a function, and then we also know how to overload an operator and what does it mean by overloading an operator. So let me just discuss about polymorphism. Polymorphism is one name, multiple use, or we can say many form of the same thing. You may have heard the word polymer in chemistry. Polymer means many forms of one thing. So likewise we have property of polymorphism in object-oriented programming, by which many things can be defined with the same name. So we have already seen compile time polymorphism through function overloading and operator overloading. Now we will see runtime polymorphism, which can be achieved with virtual function and pointers. So what are virtual functions? We will be discussing virtual functions also. So first we should understand that what is the difference between compile time polymorphism and runtime polymorphism. Why we say that some kind of polymorphism is compile time polymorphism and some kind of polymorphism is runtime polymorphism. So first we will discuss the difference, what is the difference, and then we will discuss how runtime polymorphism is achieved. So there is one word which we will be using frequently for achieving runtime polymorphism, that is called binding. What does it mean, binding? Binding is the process which is used by the compiler to convert identifiers. Identifiers means variable or function names into machine language address. So if you know, I told you that when we write, that is called source code, and that source code is converted into object code, means machine language code. So that process is called binding, where compiler converts all the identifiers, variable, function name into machine language address. So there are two types of bindings. We can say first one is early binding and second one is late binding. Early binding is when it is done before the program is run. Before running the program, when you compile your program, this early binding is done. This is also known as compile time binding or static binding, or we say it is a early binding. So when you compile your program, so some variable names and function names are converted into machine language address by the compiler, and this type of binding is known as early binding. Then second term is late binding. This is also known as dynamic binding or runtime binding. Sometimes what happens, compiler cannot know which function will be called till program is executed. Means once you run the program, until the runtime, until you reach to that particular function, compiler does not know that which function to be executed. If we have two functions with the same name, sometime until we run the program, compiler does not know that out of these two functions, which function to be executed. So at the runtime when compiler know, then compiler convert that function, this is known as late binding or runtime binding or dynamic binding. Why we say dynamic? Because it is at the time of execution of your program. So now this is the basic difference between compile time polymorphism and runtime polymorphism. In compile time polymorphism, call is resolved by compiler. Function call, which function to be called, compiler will decide. In runtime polymorphism, call is not resolved by compiler. At the time of execution, it is decided that which function to call. So compile time polymorphism is also called static binding, early binding or overloading as well. We have seen so many times function overloading and operator overloading as well. So compile time polymorphism sometimes refer as simply overloading, and you all are familiar with the word overloading. Runtime polymorphism is known as dynamic binding, late binding and overriding as well. So there are two words, overloading and overriding. We have discussed so many times what is overloading. So now we will be discussing about overriding. So just for the revision, overloading is compile time polymorphism where more than one method share the same name with different parameters or signature and different return type. However, return type, we know that return type does not play any role in overloading, only function name and parameter. Overriding is runtime polymorphism having the same method with same parameter or signature but associated in a class and its subclass. So here also in overriding there will be two functions with same name, same signature, means their name should be same, parameter type should be same, return type should be same, but they should be in different classes. One is the class, another one is its subclass, means base class and derived class. So it means when we are talking about runtime polymorphism, it is done when we are using inheritance, when there is a class and its subclass. Without inheritance, there won't be overriding, there will be only overloading of function. But if you are writing the function with same name, same parameters in two classes, one is the base class, another one is the derived class, then you can say this is function overriding. If you are not using inheritance and you are writing the function with same name, same parameter in two different classes, that is called in two different ways, in the same class, two functions with the same name, that is called overloading. But when you are using inheritance, that is called overriding. So overloading is achieved by function overloading and operator overloading, which you have seen. We know how to overload a function and we know how to overload an operator. Overriding is achieved by virtual function and pointers. So this we will be discussing that what are virtual function and how to write virtual functions. It provides fast execution because known early at compile time. So overloading is fast as compared to overriding because everything is decided at the compile time. Overriding provides a slow execution as compared to early binding because it is known as the runtime, because at the runtime it has to decide that which function to call, so it takes some time. Compile time polymorphism is less flexible as all things execute at the compile time, because everything is decided at the compile time, it is less flexible. Runtime polymorphism is more flexible as all things execute at the runtime, because which function to execute it is decided at the runtime, so it is, you can say it is more flexible. So now we will be discussing, from now onwards we will be discussing about everything about runtime polymorphism. Selecting an appropriate member function while the program is running is known as runtime polymorphism. So we have many functions with the same name, which function to call, selecting this appropriate function which to call, this is at the runtime is called runtime polymorphism. C++ supports a mechanism known as virtual function to achieve runtime polymorphism. So runtime polymorphism or late binding can be achieved with the help of virtual functions. So it is a mechanism in which method called by an object gets associated by name in runtime. Late binding happens when virtual keyword is used in the member function declaration. So now what is function overriding? If we inherit a class into the derived class, so whenever you are using inheritance and provided a definition for one of the base class function again inside the derived class, means base class and derived class both have the function with same name, same parameter and defined differently in two classes, then that function is said to be overridden. Then that function is known as overridden function. And the mechanism is called overriding. If two of the class, one is base class, another one is the derived class, both classes have the same function with same name, same parameter, then this process is known as function overriding. Requirement of overriding, inheritance should be there. Function overriding cannot be done within a class. Within the same class, if we have two functions with same name, same parameter, that is overloading, not overriding. Overriding is there should be inheritance. Function that is redefined must have exactly the same declaration in both base and derived class. Same declaration means same name, same return type and same parameter list. So now I will write a program just to show you how to override a function. So let's say we have two classes. So let's say one class is base class. My class name is base class. And let's say this class has only one public function and function name is show. Okay, without any parameter, return type is void. And what this function is doing, just to define that this is a base class function, simply we will print base. Okay, now similarly, let's say we have another class that is called derived class. Okay, and this class also have public function name is same, show. This class also has public function name is show. And what does it print? This prints derived. So this is not overriding. Why this is not overriding? Because two of these base and derived class are different classes. There is no relation. I didn't define inheritance yet. So it means there is no relation between base class and derived class. So you cannot say this is function overriding. Two classes can have same function with same name. So let's say we have an object of class base and let's say we have an object of class derived. Okay, and then we can call this function show with when I write b.show, it will call show function of base class. When I write d.show, it will call show function of derived class. No problem. Let's run it. So base and derived, this is simple. We write two classes, just declare object of two classes. Now let's say I write a pointer of base class. And when I say b1 is equal to %d, is it possible? No. Because D is the object of derived class and b1 is the pointer of base class. And there is no relation between base and derived class. Now let's say this derived class inherits class base. Sorry, public base. Now what does it mean? It means now this derived class has two functions with name show without any parameter and return type is void. Now this is called function overriding. We are overriding base class function show here inside derived class. Now derived class has two functions with same name show. It means function show is overridden. So, but things to be noted here is when you are calling it with b.show, d.show, they will call their own function. No problem. Okay, base and derived. Here I define a pointer of base class and then I assign this pointer to an object of derived class. This can be done because now base class is inherited by derived class. But my question is, when I write b1, I should write arrow or dot? Arrow. b1 arrow show, which function to be called? Derived function or base function? Because object is of derived class, but the pointer is of base class. So when I will write it like this, which function to be called? It will call base class function. Base, derived, base. But it has assigned an address of a derived class object. Just a minute. Sorry. But we have assigned an object of derived class. But it will call the function of base class. This is called early binding because once I write base asterisk b1, this b1 is binded with the base class, not derived class. So at compile time, this b1 is binded with the base class. So this is called early binding. But what we want? We want when object is of derived class, it should call show function of derived class. So for this purpose, we will achieve overriding using virtual functions. So now we will, in the next video, we will discuss how to write a virtual function and what we can achieve with the help of virtual functions. So this was the problem when you are overriding the function. This was the problem. Okay, now let's discuss about virtual functions. What are virtual functions? What are the properties of virtual functions? How to write a virtual function? So, first of all, how to define virtual functions? Let me make it on slide presentation mode. So, virtual function is a function in base class which is overridden in the derived class. So, when we have two functions exactly with same signature and same name in base class and derived class, in superclass and subclass, or in parent class and child class, then we make parent class function as virtual function. So by making it virtual function, it tells the compiler to perform late binding on this function. Means this function will be binded at the runtime. How to make virtual function? Virtual keyword is used to make a member function of the base class virtual. Like we have discussed about virtual classes with virtual keyword. Similarly, when we are defining the base class function, we will add keyword virtual just to tell the compiler that now this is a virtual function. So there are some rules associated with virtual function. First one is virtual function must be members of some class. Only a class function can be virtual. Normal functions cannot be virtual functions. They cannot be static members. Virtual functions cannot be static functions. Okay, so it means you cannot write virtual functions for static members. They are accessed by using object pointers. So the virtual functions are meaningful when you are using object pointers only. Like I write the program, I define pointer of base class and then I associated that pointer with object of derived class. So in that case, virtual function is meaningful. A virtual function can be a friend of another class. There is no problem. Virtual function of one class can be a friend of another class. A virtual function in a base class must be defined even though it may not be used. Even if you are not using the virtual function of base class, every time you are using the same overridden function of derived class, then also it is necessary to define that virtual function. The prototypes of the base class version of a virtual function and all derived classes versions must be identical. Means their name, their parameter, everything should be identical. Then only there is a meaning of virtual function, because then only overriding will be exist. If it is not so, some functions will be different prototypes. C++ will consider them as overloaded function, not overridden function. We cannot have virtual constructors. We cannot have virtual constructors, but we can have virtual destructors. That we will be discussing later, that how to make a virtual destructor and what does it mean, why it is useful to write a virtual destructor. While a base class pointer can point to any object of the derived class, vice versa is not true. You cannot write a derived class pointer that will be pointing to a base class object. That will have pointing means that will have an address of base class object. That will be an error. I'll show you. When a base pointer points to a derived class, incrementing or decrementing it will not make it point to the next object. For example, you write a base class pointer that is pointing to an object of derived class. Once you increment it, automatically it will not point to the next object. Okay, this is pointer arithmetic will not work here. If a virtual function is defined in the base class, it need not to be necessarily redefined in the derived class. It means if you write a virtual function in the base class and you write the function with same name in the derived class, but you do not define that function, you only declare, it is perfectly okay. In such case, call will invoke the base function always. Okay, there won't be any error. I will show you. So last one thing is virtual function and second thing is pure virtual function. So pure virtual functions are virtual functions with no definition. When you are not defining virtual function, that is called a pure virtual function, and they start with virtual keyword and ends with is equal to 0. For example, f is a function, virtual void f is a virtual function, and you do not want to define them, then you will write is equal to 0. So once we write is equal to 0 for a virtual function, this is called pure virtual function. Where we use pure virtual function, that we will discuss later, but as of now you should understand that what are pure virtual functions. So now let's check how to make a function virtual. So the same example here, I write it base class, derived class. Just now I write base class, derived class, and both class are having function, show function with same name and same prototype. The definition is different. So what I did, I declare an object of base class, I declare an object of derived class. Then with base and derived, I call show function. So they are calling their own function. Base class object is calling base class function. Derived class object is calling derived class function. Now after that I declare an pointer of base class, and I associated this pointer to the object of derived class. But because of early binding, this pointer has been associated with the base class. When I write b1.show, it will call the show function of base class. However, it is assigned the address of derived class. So let's run it one more time. Like this, base, derived, and base. This is called base class function, this is called derived class. Again, this is calling base class function. But what we want, if we are associating this pointer with the object of derived class, we want when we write b1 arrow show, it should call the derived function, show function. It should call the show function of base class. So derived class. So here we make base class function as virtual. So now this is virtual function, and as soon as I make this function virtual, it will tell compiler that this function, binding of this function should be late binding, not early binding. So when you make it virtual, everything is same, base strict b1, pointer is of base class, b1 ampersand d, b1 show. So when I run it like this, it will call, now b1 arrow show will call, you can see here the difference, now b1 arrow show will call show function of derived class, because now that show function is lately binded. And when lately binded, it means because the address we will assign at the runtime, because address has been assigned of object d. So now it will call the function of derived class, show function of derived class. So this is how we can make a function virtual. Vice versa is not true. If I write an object pointer of derived class, let's say d1, and I want to assign this pointer d1 to address of base object b, this is not possible. This will give you an error. However, you can give an address of object of derived class to the pointer of base class, but vice versa is not true. It will give you an error. Base cannot be assigned to an entity of type derived. So this is not possible. If you are not defining this function, let's see what happens. Okay, let me check one link, just a minute. If we are not writing it at all, then it will always call show function of base class. Then it will always call show function of base class. So this is how we use pointers. This is how we use pointers and virtual keyword to achieve runtime polymorphism. This is called overriding or runtime polymorphism. So in the next video, we will be discussing about what are abstract classes, how to make a class abstract, and then we will discuss about virtual destructors. Okay.